Okay, so here we have differential equations, and we're going to use Euler's method by step the size to find the value of at 4.5. Okay, now I've not done this one yet, so it's totally cold what I'm doing, so bear with me as I make my errors along the way. So what I do know is that Euler's theorem says n plus 1 is going to equal to yn plus h, which is our step, times the derivative of n, let me do it, not n, but I'm going to make it n minus 1. So make this n minus 1, n minus 1, y, n minus 1. The idea here is these refer to each other in the sense that this is one and this is the one beforehand. This here is the derivative, so it's the slope. So on our starting point, which is 4, 4, so imagine I'm at 4, 4. Okay, what I can do is I can find the slope of the tangent, whatever that would be, and then I can find the equation of the line, and if I go over and then up, I get this value. So the y value here, this is going to be yn xn, and I know that xn is going to be, well, if this is 4, 4, well, the next value is going to be 4.1, and then the y value, whatever it gets. Okay, and then what I'm going to do next is then from this point, I'm going to find a new slope, go over and up, and then this value will have a y value of, or an x value of 4.2, some y value, and so on and so forth. And we keep on, and what happens is when we get to 4.5, we'll have a point that's pretty close to the actual value, and it's going to be an approximate. So let's go through this. So when I do this, it's going to be y sub n is equal to yn minus 1 plus h. The slope is here. It's going to be times the square root of whatever x minus n1 over 4 times y sub n minus 1. So I'm going to set up a table, and it's going to be xn, yn. If n is 0, well, I get my first point, which is x value of 4 and the y value of 4. When n is 1, I want to find when n is 1. That means I'm going to do y sub 0, which is 4. Oh, actually, I'll put 4, y sub 0, plus h, which is 0.1, times the square root of x sub 0 times 4 y sub 0. Okay, and so when I plug these values in, it's going to be y1 is going to equal to 4 plus 0.1 times the square root of 4 over 4 times 4. And if I do it by hand, I get 4 plus 0.1. Those 4's cancel. That's 1/4. Square root of 1/4 is 1/2, which is 0.5. So this value, I go 0.1 times 0.5, 0.05. So this is 4.05. So what this is saying is that when I go to I add my steps, so this is 4.1, this is going to be 4.05. So I go over 4, this point here will be 4.1, comma, 4.05 is the y value. Then I'm going to find the slope at this point. Okay, but because it's an iterative process, they've come up with a formula. And what you have to show on the test is you have to show, so here's my formula. I have to show yn equals yn minus 1 plus 0.1 is my h, square root of xn minus 1 over 4yn minus 1. This is what I have to show. This is the equation I'm going to use, and I'm going to do the table. And so to show you what's going to happen, I know my very first value is n is 0, my minimum. My x values, this are my x, is going to go, each value, I'm going to add 0.1. Enter. My first value is going to be 4, because it's the 4. The y value is going to be this equation here is what I'm going to put in. So I'm going to clear that and start all over. So I'm going to go the value of n minus 1 plus 0.1 times the square root of parenthesis my x value of n minus 1 divided by, and I'm going to put parentheses 4 times the y value of n minus 1. Oh, forgot my parenthesis. Close it, and that will be the formula I use. And I know my first value for y is also 4, enter. Okay, and so when I go to my table, this is what I should get when n equals 1 if I've done it correctly. Fingers crossed. I'll check my table set. I'm going to start at 1 and go by 1s. And I go to my table. And so 4.1 is 4.05. 0 is 4 and 4. And so I'm looking for, the other thing I have to write on my test is this whole table. For 5, this is 4.2. 4.3, 4.4, and 4.5, and I get 4.1003, and so on. And so Euler's method estimates the value at 4 to be 4.3044. That is what we get here for the y value of 4.344. And so if we would actually have the true equation, maybe that might be the true value, and so the approximate will just be probably a little bit less. But it takes little approximations to get closer and closer to the curve, and so it's a pretty good approximation of the true value.